In this problem we have 1975a before. Given the function defined by y equals x plus sine x for all x, such that x is between negative pi over 2 and positive 3 pi over 2, we want to find the coordinates of all maximum and minimum points on the given interval. Now the fact that this says all maximum and minimum points, I think that we're looking for relative max min as well as absolute max min. And we're going to start with the derivative, or the first derivative I should say. If f prime of x will be equal to 1 plus cosine of x, and we want to find where that's equal to 0, and that'll be when cosine of x is equal to negative 1, or x equals pi. And just for safety's sake, I'm going to go ahead and make a sign chart to see whether pi is going to be a relative min or relative max. So I'll choose two cosine friendly values, 0 and 4 pi over 3. At x equals 0 I'm going to get 2, which is positive. At 4 pi over 3 cosine is negative 1/2. And that would indicate that the function is increasing over the whole interval. If you look at it, 1 plus cosine of x, cosine can only go from negative 1 to positive 1, and so its minimum value is going to be 0, maximum value will be 2, and so even though we do have a horizontal tangent at pi, the function is never negative. The derivative is never negative, and the function is never decreasing on that interval. And so we only have to test the endpoints in that case. So we're looking for f of negative pi over 2 into the original function. That's going to give us negative pi over 2. And sine of negative pi over 2 is going to be negative 1. So that's negative pi over 2 minus 1. So f of 3 pi over 2 is going to give us 3 pi over 2. Sine of 3 pi over 2 is also negative 1. And so I record the coordinates for the absolute maximum and the absolute minimum there. Second, we want to find the coordinates of all points of inflection. And if the first derivative is 1 plus cosine x, the second derivative is going to be negative sine x. And that will be 0 whenever sine is 0 on the interval from negative pi over 2 to 3 pi over 2, and that will be at 0 and pi. So we make a sign chart. Fix those n values to be from negative pi over 2 to 3 pi over 2. Select some coordinates, some sine friendly coordinates, and we're going to plug them in. So at negative pi over 6, sine is negative 1/2, and we want the negative of that, so we get positive. At pi over 2, sine of pi over 2 is 1, and we want the negative of that, so it's negative. Sine of 7 pi over 6 is negative 1/2, and we want the negative of that, so it's positive. And so the points of inflection will occur at 0 and pi. And since we do need the coordinates, I plug in 0, 0 and pi, pi. So now we're ready to just go ahead and graph that, and let's see what we get. Pi is 3.14, pi over 2 is 1.5 roughly, so negative 1.5 minus 1 is negative 2.5. So we plot that point. We also have 0, 0. At pi over 2 we have pi over 2 plus 1, so that's roughly 2.5 positive. At pi we have pi, and 3 pi over 2 is roughly 3.5. So we've plotted our points. We need to take care of the concavity between them. So from negative pi over 2 to 0, it's concave up. So we're concave up again from 0 to pi over 2, and I mark that. Sorry, negative pi over 2 to 0. Concave down from 0 to pi, and then concave up from pi to 3 pi over 2. Again, if you feel that the graph is not as clear as you'd like it to be, you can put those arrows in there to show where the concavity is. You might put a dashed line in there to show where the points of inflection are. And if you want to label them, you can label them too. But that should do it for this problem.